We will work on in-class exercise 4 for the topic dot products, chapter 2, topic 2.9. For this in-class exercise, we will work on problem 2.128. Determine the angle theta between BA and BC. So we have been given this pipe assembly and force F is applied at end C of the pipe, and we would like to calculate the angle between BA and BC. So let's work on it. So this is the given pipe assembly. Remember that the order of the vector has the direction, so this order is really important. It's BA and BC. So step number 1, and there are 3 important points here: A, B, and C. So first step is get the coordinates of these points relative to the origin, and origin of the frame is at B, which is 0, 0, 0. So B itself is at the origin, which has X, Y, and Z coordinates 0. X is positive going this way, Y is positive here, and Z is positive going up. So let's calculate the coordinates of point A, B, and C. So point A is at 0 in X, minus 2 in Y, and 0 in Z. That is the distance from the origin. For point B, it's 0, 0, 0 meters. And point C is 3 meters in X, 4 meters in Y, and minus 1 because it is below XY plane in negative Z direction. So Z is positive from B and going up, and C is below that. So it's 3, 4, minus 1 meters. So that is the step number 1. Now next step is we need to draw the vectors, because we need to calculate the position vectors or the unit vectors for the direction. So it's BA. So BA is at B, it's the tail, and going to A. So going from B to A, this is the direction of the vector, and that's this blue vector here. And the second one is BC, which is this red vector going from B to C as shown in the figure. So next, to calculate the angle between the vectors, there are 2 different ways we can solve the problem. Is we can write down the equation of the dot product, that is R BA dot product R BC is equal to magnitude of the position vector going from BA multiplied by magnitude of the position vector going from BC. Remember that this is dot product, this is not multiplication, and this is multiplication. Multiply by cosine of angle between them, which is theta. However, we can also, instead of using the position vector, we can also use unit vectors. So unit vectors going from BA with unit vector going from BC is equal to magnitude of unit vector BA, magnitude of unit vector BC, and cosine of angle between them, theta. So this is the angle theta. Now this equation, they both will give you the same result for calculating the angle. However, this makes a little bit easy the calculation because the magnitude of the unit vectors are 1. That's why they are called unit vectors. So all we need to do is we need to just calculate the dot product of the directions for BA and BC. So, and that we can determine from the position vector. So let's work on it. So for UBA, we can calculate it by dividing the position vector going from BA by its magnitude. So, and that is 0I minus 1j plus 0k. Okay, and since this is the unit vector, it does not have any unit. Second, UBE, so BC, going from B to C, that means coordinates of, this can be written as position vector going from B to C divided by R BC, the magnitude. And this is nothing but coordinates of point B minus coordinates of point C minus coordinates of point B. Remember, it's always head minus tail. So it's C minus B divided by RBC. So if it is BC here, then it is C minus B. It reverses the direction because BC, the B is the tail of the vector and C is the head of the vector. Okay, so we can, based on the coordinates value, we can say that this is 3 minus 0 for x coordinate multiplied by the direction, 4 minus 0 for y coordinate multiplied by the direction, and -1 -0 multiplied by direction for z-axis, which is k, and magnitude is square root of what numerator, the magnitude of the numerator, which is 3 square plus 4 square plus -1 square. Okay, and this is 3 divided by square root of 26i plus 4 divided by square root of 26j minus 1 divided by square root of 26k. Now this does not have any unit as well because that's the unit vector. So it's time to substitute both of these magnitudes, both of these vectors into this equation and calculate the dot product of them. So dot product UBA dot UBC is equal to dot product of 0i minus 1j plus 0k and then dot this second vector, which is 3 square root of 26i plus 4 divided by square root of 26j minus 1 divided by square root of 26. Okay, so basically what we need to do now is we multiply 0 with this number, which gives us 0, minus 1 multiplied by this number gives minus 4 divided by square root of 26, and 0 multiplied by this number, again that gives 0. Okay, so the only number that we care for is minus 1 multiplied by 4 divided by square root of 26, and that's minus 4 divided by square root of 26. Okay, so this is one equation for the dot product, but we know that angle theta can be calculated simply by cosine inverse of dot product UBA UBC divided by the magnitude UBA UBC, and the magnitude UBA and UBC is 1, so this is cosine inverse of minus 4 divided by 26 only, because these two values are 1, magnitude of unit vectors are 1, and the final answer is 141.67 degrees, or rounded to 3 significant figures, it's 142 degrees theta. That's the angle. Thank you.